The slides and the paper that's on this topic I'll have in the downloads pod near the end of the presentation in case you missed it at the opening. My first question for you is a question I ask my customers or clients, I ask my students, I ask just about everybody I deal with is well, how do your customers talk about reliability? What is it that they do that conveys what they want in regards to reliability? And I've heard everything from I think one of my favorites was a customer that said, I understand this product may fail and that to be in business, you have to accept that risk. And that's fine. You can have a 90% reliability target for your product. Just make sure you send me one that works. And so it was, how do you interpret that? Um, Another one says, I just want it to work. I just don't want it to fail. You also hear that when you go to the car dealer. I just want my car to start. That's all I really need. So how do you talk about it? How do your customers talk about reliability? Go ahead and use the chat window, and we'll use that to make it work. See, a couple of people are typing. Hopefully the sound's still working. Uptime, availability. I get that a lot in factories, in high availability kind of things. And Chris, do they use percentages or do they use some other way? No warranty issues. Warranty is a cost, and we track that cost. Yeah, Richard, you know my opinion on MTBF. We'll get to that in a minute. Total cost. So is that how your customers talk about it, or is that how you talk about it? So some customers use MTBF. I've heard that a lot before. Customers are OEMs, a little more sophisticated. Okay, so customers range everything from, in a consumer market, they just want it to work. In talking about your car, they may be talking about availability. They want it to work when they turn the ignition or push the button nowadays on some cars. Some customers are more sophisticated and will say, I want 98% reliability over the first year. And say they're buying thousands of disk drives, and they may actually track that. And of course, yeah, I see lots of MTBF here. And uptime and downtime availability, those kinds of things all get blended together. So thanks. Let's take a look at my. One of the things I find, though, is that customers and the people we work with generally don't use the same definition that we use as reliability professionals to talk about reliability. We often see the word reliable or reliability in advertising. I'm quite sure you can think of one or more advertisements or even data sheets or websites that says we have the most reliable product. I have seen for years between Verizon and other telecommunications carriers the most reliable network. Well, what in the world do they really mean? How are they defining that term? And sometimes you dig into the details behind a claim, and it's not an engineering definition. It's more of the definition of it's trustworthy or dependable or always there for you. For example, I saw a truck a couple of years ago that was a great big banner across the side of it saying reliable movers. And I think that was the name of the company. It was a moving van to move furniture and household goods and so on. How do they measure reliability or define it? And I think it conveys, or was intended to convey, the more common definition of the term reliable or reliability is that they would show up on time, they would package and move the goods such that they didn't get damaged, and they wouldn't overcharge you. They were more on the trustworthy side of things. When we talk about reliability of our product, it is not uncommon that this common use definition is in the minds of the people we deal with. They're rarely thinking of the probability and the way we think of it as a reliability professional or as an engineer. So what is the definition of reliability from an engineer's point of view? What do you think? How do you define reliability? And please don't say MTBF. They don't steal your stuff. Yeah, George. Hopefully they didn't have to explain that to anybody in the moving company. But in your work, in your way of dealing with reliability, how do you define it? Suppose when you signed on for this webinar, you didn't expect to have a quiz, but I'm curious as to how different people view this. Probability of failure at a given product age. There's two parts in that, probability and duration. Expected performance and use case. There's a function and environment. Repair per 100 in warranty. Okay. That's a detailed one that looks at the failure times. Maximum life cycle. Maytag repairman. Like that one, George. Warranty. Okay. So this goes into a little bit, as we saw when I first started, as how do your customers talk about it. And I saw a couple of them from a couple of folks that have the elements I was looking for. And I remember years ago when I was working at HP, I picked up a new textbook on reliability engineering, and my boss said, "Hey, let me see that." And he opened up the first page of the first chapter and said, "They don't define reliability. How do we know what they're talking about?" And what I'm looking for is, well, if I have a definition of reliability, if I open up the dictionary, it has trustworthiness and it has dependable. It means that you'll do what you say. Essentially, it's you'll always be there. You can be counted on. It kind of muddles what we really mean when we say reliability from an engineering point of view. And so my boss was looking at a textbook and saying, and if you open up the Iris, Coombs, and Moss Reliability Engineering and Management Handbook, or the book by O'Connor and Kleiner, the 5th edition of the Practical Reliability Engineering, right on the first page, it defines reliability. And so do many, many other books, with 4 elements. What's the function? What's the environment? What's the probability of success? And over what duration? We'll dive into that in more detail as we go. But I was preparing for the same guy I was working for back at HP. We were looking for imagery for a presentation. We were starting a reliability group within HP, and we wanted to do a presentation. And so one way to define reliability is to use an image. So at the time, we had an image library in the company, and it had the ability to look for keywords. So I typed in reliability, and I got a picture of a German Shepherd and a couple other dogs type images. But that was it. That was how HP's marketing group thought of product reliability. And later, as I started my own consultancy, I started to look for imagery, what other people were using for images of reliability, as a way to help define it, use the visual imagery to help define what I mean by reliability. And defining it as Adriano has here is the probability your system will perform a certain period of time under certain conditions, has those four elements in it. And it's not tied to a specific industry. So using a picture of a car would imply that reliability has to do with the auto industry. If I used a medical device, I would be isolating to the medical system. But what image comes to mind as you look at without isolating it just to one industry or one kind of product? Well, German Shepherd is what our marketing guys at that time came up with, and I'm still struggling with this. So I'm curious if anybody's found the right sets of imagery to make this work. But it is a relatively intangible part. Our concept is that it works without failure under certain functions and conditions. And there's a lot more that goes into it, but as we think about our products, we don't have a Kleenex type brand for tissues, imagery for reliability. There isn't one common definition that everybody thinks of and visualizes as they go into it. So my point with how customers talk about it, how we talk about it, how we define this term, along with the imagery, all bundled together, is that there's a lot of confusion in potential misunderstandings about what we mean when we say, I want a reliable product. So getting into a real definition certainly makes a lot of sense. So I'm going to reflect on this one just for a moment, is how do you talk about reliability? And I saw a few people pull out the definition, but not when I talked about how do your customers talk about it, or how do people in general talk about it. So there's a bunch of information about failure rates, about functions, and so on, but it's that four-part definition that makes the most sense to me. It's what's the function, what's the environment? Environment includes the use case. What's the probability of success? This is our realm of statistics that we get into, and I see MTBF, annual failure rate, a handful of these other ones are related to the probability piece, and then duration. What is the period of time that we're dealing with? So annual failure rate implies over 1 year, 1 year of use. And so we'll get into each of these a little bit more detail. And if I have it set up correctly, I've got a quick poll here, and I think it's open. So return count would be like counting how many phone calls you get at a call center, or how many failures you get coming back in. So I think you can vote on this. Go ahead and pick one or more of these. And I did see a couple people using annualized failure rate, so surprised I don't see any numbers there. There we go. So this is how do you, we often use the word reliable, and here I'm meaning that it's in the connection with function, environment, probability, duration. And as reliability professionals, I would expect we use this kind of result. So I'm seeing most people picking reliability, handful with duration, annualized failure rate. Let's see what else is coming in high. Yeah, I think that's about it. All right. The hard part is, how do we actually do this? How do we create a reliability goal, especially when we have so many other ways we talk about it and ways our customers expect it to happen? So let's take a look at each of these things in a little bit more detail. So function. most organizations have a products requirements document or a specification sheet or even a data sheet that says this is what this product is supposed to do. That's the function. And for a reliability goal, I often advise people to have a short 1 or 2 sentence goal statement. And if we list the entire product requirements document, the 150 pages that may be involved in that, detailing every button and switch and color and size and weight and so on, it'd be unwieldy. Yet what's the primary function? I have no idea what this image is supposed to do. Yet if I have a cell phone, for example, I might say the function is to make and receive phone calls, or to be a data portal, or fill in the blank for your product. A short phrase of what's it supposed to do, what's its primary function. And if it doesn't do that, is that quantify or is that detail what a failure is? So the product requirements document says what it's supposed to do, and maybe even gives specifications and boundaries of help us define what a failure is. So the purpose of the function in making sure it's clear with your company, with your design team and development team, with the factory floor, and with your customers is by clearly knowing what it's supposed to do is we inherently define a failure. And sometimes that's a gray area. And where that occurs, make it explicit. If it's supposed to make and receive phone calls, it should make and receive phone calls. And no gray area. Let's define it. It should be pretty obvious. But if your product has lots and lots of features, what's its primary function? And use that as a short phrase in a reliability goal. Think of it as an elevator speech. I don't have time to define reliability for this product for every one of its features. Yet, if it's supposed to provide a sharp edge or open wine bottles, for example, the corkscrew, is that its primary function? Or maybe it's intangible. It's to provide an array of convenient tools. That would be fine too. But what is it that it's supposed to do? That's the function. It should be pretty easy. The environment, though, can get pretty messy. So for your product, or for a product you're familiar with, or even pick a product that's on your desk, how do you define the environment? How do you specify what's the environment? Not a rhetorical question. It's another one where I'm looking for a chat window. How do you see the environment defined? Stresses and conditions. So I've often seen temperature, John, as a stress. I've seen it from students over and over again where they say the Swiss Army knife is supposed to work in temperatures from minus 40 to plus 80 degrees Celsius. The stress profile. I've seen stress profiles for like aircraft where there's a certain set of range of temperatures based on tarmac temperatures. It could be very cold or very hot and humid. And then at altitude, very cold, wind stresses, all kinds of things come into mind. User application. So Mark, you're closer to what I'm looking for is what's the general place the customer is using the product? What's the general way they're using the product? So for a Swiss Army watch or for a cell phone, we could say outdoor portable. It's kind of based on the old mill standards, the old standards that talk about the general conditions of where the product is. So for servers and large hard disk arrays and cloud storage type facilities, data centers is another way to phrase it, is they were indoor sheltered or protected environments. If you're making a satellite, it's outer space. And just by saying the environment is outer space, it implies or could reference a document that lists the vacuum, the solar radiation, the temperatures, the temperature changes per day, the source of energy, the power supply system, or whatever. When I look at my desktop computer, it's home or office. It could be at a storefront. It could be on a factory floor. Usually it's indoors, not always, could be indoors, but it's not just the temperature range. It includes vibration and dust and the opportunity to be knocked off the desk or drop damage. So like Alex, where you're listing humidity, UV, vibration, voltage, stresses, there's a military handbook, I think it's 810, lists a whole range of different types of environmental stresses, everything from temperature and vibration off to fungus and insects. As an aside, I ran into a lab in Texas once, and I noticed there's a couple people from Texas online. There's a lab that has testing for fire ants. And if you're from that part of the world, you know that these small ants have a pretty mean bite, and they're not afraid to bite you. And it turns red and swells up. I remember it distinctly from when I was stationed in Texas and discovering fire ants for the first time. Apparently, they like low voltage. So when people were first putting the power meters, their electric service meters, in underground vaults, basically underground the wires coming into a home, there'd be a little box placed a couple feet underground. And what they found is the fire ants were attracted to the electric field and would eat through all of the seals and everything else and then destroy the power meter. So there became a laboratory that now tests for susceptibility for fire ants. Not a test I would want to run or be in charge of, given the critters. But if you specify just a short list, it might be based on what's most important. When we set a reliability goal, it's try to create a image or a picture in your team's mind or your organization's mind, your customer's mind, is where and how is this product used? So it might be outer space, it might be outdoor portable, it might be in a data center. Usually we have a shorthand way of describing both the range of weather conditions, and generally we have another document that lists all of the different environmental conditions, temperature, vibration, fire ant susceptibility, fungus, on and on and on. And we also generally have an idea of, is this product used 24/7, say in a data center? Is it only used on a frequency type approach, like this bridge, the Golden Gate Bridge, sees heavy traffic in the commute hours, in the morning and the afternoon, as people are crossing the bridge to get to or home or to work. At rest of the time, it sees a much lower load, and that provides a stress profile for the structure itself. So whatever it is, usually like the function, we can define it with usually just a phrase. What's the basic environmental conditions or environment that this is used in? So if I'm using a cell phone, for example, I'd say outdoor portable, which implies the envelope of temperatures and stresses and conditions and a use profile of being portable and susceptible to a range of different failures that is different than a phone that is attached to the wall, for example. So let's get into the two that I think are the more where I talked about unexpected uses, environments, and the fire ants. I forgot I had this slide. I used to think that the under the hood of an automobile was a difficult environment. I also have run into the oil industry where they do exploration, and they're putting electronics into the drill string right behind the drill head. So within a few feet of this cutter, essentially cutting through solid rock. And they describe the environment as 50,000 G continuous shock, 200 degrees Celsius hydrosulfuric acid bath, and this torsional, as the drill gets caught on something, the drill string winds up like a spring, and so whips the electronics and provides a torsional stress on the electronics. And so I have found that to be one of the most difficult environments to create products. What other environments have you run into, or what other strange things have you gotten to do? A handful of medical devices I've worked with, I've just had a whole new appreciation for sweat resistance. Yeah, Neil. I saw a formula for artificial sweat. It had a very short shelf life before it got turned kind of rancid, but it would test finishes on products and paint fairly well, especially if it's a product that's used like a cell phone or in your hands, like a game controller or lots of other products. I was going to say is the inside the human body, even though it's a relatively stable temperature, the body itself doesn't like products or anything inside of it, so it tends to isolate it or build a calcium deposit around it if it can't actually destroy it. So by specifying temperature, we might be in great shape. But if we're not dealing with how the body reacts to foreign objects, then we're not quantifying the environment completely. Yeah. Every product has a place that it needs to work. And one that really surprised me years ago was we had computers, CAD system, workstations that were returning with lots of corrosion. And when we asked the customers where they were using this product, it was in the Detroit area in automotive companies. And they said they were using it inside the laboratory where they made the clay models. Well, the clay they were using had a lot of sulfur content in it. So one of the byproducts was a sulfur dioxide or a sulfuric acid byproduct that the fan system, the cooling system on the workstations would pull all of that contaminated air into the electronics and basically coat all of the sensitive electronics with sulfuric acid and its byproducts and cause a lot of damage and corrosion. So if we just make a short list of environmental conditions is part of our goal, we often miss the other pieces that are involved in it. So I highly recommend for the function and environment to make it a broad, succinct statement to provide a visual of what we're really doing. So what I've pulled up here is a cumulative distribution function from some data I had from a few years ago. And I want to start with the probability part of this discussion and duration. And I'm pulling up a CDF because I found it to be the most convenient way to link these two things, the time, the duration, or number of cycles if you're on a machine in a factory floor, number of cycles of output that it provides, and then unreliability on the vertical axis. The idea is that see if I can pull up a drawing tool here. So one of the things is that at any point in time, let's say we're interested in a product that has less than a 1% failure at, this would be 200 hours here, if I can get my drawing correct. But they're linked, they're connected. So anytime I talk about probability, I want to talk about duration. Anytime I talk about duration, I want to imply or specify a specific reliability, or in this case, unreliability. So this could be 99% reliable at 200 hours or 200 days. If I have the scale right here, oops, days. Now that could be one couplet, one specification of way to do it. Now at 10%, if we set our goal based on our actual data here at, see, 3, 4, 5, 600 days, a little less than 2 years, would be all right. Now, I have the hindsight here of our previous product. And if we're going to make it for a 2-year product, we're probably going to have to fix whatever this failure mechanism is. Now, let's say I don't have the force or the hindsight of a previous product or the elements of history, or all I have is a prediction. Is that sufficient to set a reliability goal? I don't think so. So let's say I want a product that has a 3-month, a 2-year, and 5-year. And I'm basing this on a product that I was very familiar with early in my career as a reliability professional. It was an inkjet printer. They really wanted a low failure rate in the first 3 months. They wanted high customer satisfaction because if you bought a brand new printer for, say, $500 and it failed within the first couple of weeks or first couple of months, we found that it had a huge hit to customer satisfaction. We also provided a 2-year warranty on the product, so they also wanted that to be relatively low. And then 5 years, they really wanted the product to survive so people would buy more ink for that particular product and not switch over to a new brand. They found that if we set this at, say, 98% reliable over 2 years, the 98 became part of a financial calculation. Is if we knew what the cost per failure was, and say it would cost us $2,000 per failure of a printer that originally retailed at $500, that includes the cost of replacement, it includes the cost of failure analysis and troubleshooting, call centers, and all of the overhead that goes with a product failure. We could calculate, based on the profitability of the product, how many failures we could afford. So this point, 98%, we can derive with our financial friends. What's the budget for failures? So what's the cost per failure? What's our warranty period? We can kind of back into this calculation and set that number. Well, what about the other 2 points? How do I come up with those? So the initial one, or the early life failures, is often based on customer satisfaction. If you're entering the product from a position of strength and you already have reliable products, as HP did, we used historical data to say that if we're not better than 99.5, we lost sales. Now this is only amplified now with the use of social media. In some markets, like the medical industry, the markets are so small, they all talk to each other. So if somebody tries a new medical device and it doesn't work, they may talk about that experience at a conference or online or on a review site. And it will damage the possibility of selling to other people. The cost of sales will go up. In other products, it's maybe contractual. Each of these numbers could be contractual depending on what your customers require. But generally, this early life is based on customer satisfaction. End of life, I've seen this done a number of different ways. One is by customer satisfaction. One is by repeat sales. And another is by some technical reason to set the limit. we have this failure mechanism here that we don't have a solution for, but it lasts long enough that after, in this case, 600 hours or 600 days, about 2 years, this failure mechanism starts to show up. So if we set our warranty at 2 years, we're not on the financial hook here. But is this long enough for customers to actually derive the value from it? So it's a little bit different way of thinking about how do you set the goal. So for inkjet printers, it was primarily a financial and a market share, or a market, what do they call it? A chance to repurchase, the probability of repurchasing. So if your HP laser printer lasted for 5 years, the likelihood of you buying another HP branded laser printer is relatively high if it lasts for 5 years. If it only lasts 2 years, it has a much lower probability of repurchase. And so the cost of finding new customers versus the cost of a resale is the difference, and it helps set where this goal was. Of course, this varies by market, by type of product, and so on. But the idea is that each of these 3 points are not set based on a reliability distribution. We may use this information to help us understand what's technically possible or where we can actually achieve, yet the goals themselves, the probabilities and the durations, should come from our customers and from our business expectations. The intent is to create goals, probability of success, and duration couplets that are connected to customers and business expectations. Let's see, I think I have to get rid of my drawing tool before my slide advance will go. I've heard a few times from people, and I didn't see it in the comments today, that duration is MTBF. So I'm glad nobody here is saying that. If you have, please direct them to the nomtbf.com site for further explanation, and hopefully set them right. It's clock time, or it's cycles, or whatever counts in your market for your product as duration, but it's essentially the quantification of time of use over time. And coupling that with the probability, and I often use the 3 different areas: early life, useful life, or warranty, where you're financially under the hook, and then end of life. For a factory, it may be, or an aircraft, it may be mission time. It may be time until refurbishment. It may be whatever makes sense for your market, for your area. But there's no reason the reliability goal has to be the cell phone provides the function of receiving and making phone calls in an outdoor portable environment for 2 years with 95% reliability. Is that sufficient to really capture what that phone is supposed to deliver? The early life failures we often point at as buyer's remorse, or not setting it up correctly, or factory defects, or transportation installation problems. It's a different class of defects, typically, not always, but typically. So setting a goal specific for that certainly helps bring the focus on meeting that requirement. The useful life, or the part where we're financially responsible for the product, is the way I've seen it mostly done, is what we commonly say and use with our customers: this is how long this product should last. And that provides not necessarily early life information or end of life information. End of life is the one I see most commonly used. It's when the wear out functions start to occur, or when we want to obsolete this particular product. So those are 3 different ways of thinking about reliability for our product. They generally have different types of failure mechanisms or failure expectations. But when you tie that couplet of probability and duration to your customers, customer satisfaction or customer expectations, to financials within the business, or to technology, or to customer satisfaction, or to sales, repeat sales. It allows us to create goals that are meaningful for the rest of the business and for our customers. Does that make sense, Danny? Hopefully for all of those different ways we've mentioned talking about reliability, everything from AFR to availability to all these other ones are just a shorthand that you're using, that you're already doing this. And what I'm suggesting, as you establish reliability goals, that you make those connections very explicit. Yeah, Tim, I tend to avoid using infant mortality given the number of medical device clients I have. Medical guys don't like talking about infant mortality for obvious reasons. What I found over the years is that we all talk about exactly the same things in all these different industries. We just want the thing to work. It's by being explicit and being careful about how we say what is the reliability and using all four elements is that we can eliminate a lot of misunderstanding or confusion. And so for many of you, I recognize and know that you've seen many of my work in the past, especially on the no MTBF side. When I say MTBF, it's just one piece of the four elements of reliability. So in shorthand, we often can say, I want a 50,000 hour MTBF over 2 years. And if you get a startled or confused look or questions from the other party you're talking to, you might want to expand on what you really mean. I would rather say, I want 95% of these units to work for 2 years without failure. And I want it to be provide and receive phone calls in an outdoor portable environment. Now, the function in an environment we often assume because we are working and talking about a particular product. But as you write reliability programs, as you write reliability goals, include the function and environment and reference the larger documents that fully detail it. Then as you write probability and duration couplets, write a short sentence or two about how that's connected to your business or to your customers. And so as we create these goals, and I've got an exercise here for you to actually give it a try. Took me a little bit of work because I knew there was the original cell phone. You know, how did they set a goal for this thing? They put a huge investment in setting up the first cell towers, essentially, and the infrastructure to enable a wireless telephone to actually operate. Sort of reminds me of when they first made automobiles, they called them horseless carriages. So the first phones were called wireless telephones. Now we just call them wireless, or we call them a cell phone based on the technology of their connection. The idea here, though, is in the chat window or on a piece of paper, write a one-sentence reliability goal. And I already gave you 2 pieces of it through its function is to make and receive phone calls. I don't even think this one could do text messages. Probably not. It might have functioned as a beeper if you're old enough to remember those, or pagers. But it's a simple phone, make and receive phone calls. And outdoor portable, we could safely say, was its environment. So what's a 1 or 2 sentence goal if you were on this team and had to write it? Clear, continuous connection, good. That talks to the quality of the function. Battery life, yeah, I think this thing was half battery, if I remember right. Um, that, again, is part of the function, right? All right, I'm looking for a whole sentence. What's the reliability goal for this product? And you can make it up, not knowing what their business conditions were at the time or what their customers' expectations were. So I'm sure a couple of you've gotten this. It's connects 99% of the time until the next version comes out. Yeah, which was probably about 6 months later. Now it's every 3 months. What I'm driving at is that if somebody asked me, what's the goal for this product? What's the reliability of this product? I would say this Motorola Dynatac 8000X is a cellular phone or a wireless telephone that enables you to make and receive phone calls in an outdoor portable environment. 99% of the functionality, or with 99% operation or without failure, I should say, 99 out of 100 times without failure for a year. And you could use 99 at 3 months, 95 at 1 year, and 90 at 5 years, or whatever. But I generally say its function over 1 year with 95% reliability. Yeah, John, now you got it. So the idea is that then expand that to, it will operate with 99% reliability over the first month and say 90% over the first 5 years, or the 2-year contract that you have with the customer or whatever. But I think John's got it right. It's make and receive calls, indoor, outdoor environments, and there's a call to a quality or a functionality criteria, so you can define failure, and then for the entire year for 95% of the time. Expand that just slightly for the early life and for the end of life, and you've got a complete reliability statement or goal statement. And it doesn't take too much work then to figure out, well, how do I tie that to my customers or to my business? And customer satisfaction, warranty or service contract type, their cost of ownership, and propensity to rebuy for some products, brand loyalty, indicators for end of life, those kinds of things. So with that, let me pull up the last piece here, which also has the question and answer tab in the upper right hand corner. You still have the chat pad, and I also have the download. The slides are here, and the paper that I wrote on reliability goals, similar to what we talked about, and then a handful of other links that you're free to take a look at. That is, it takes a little practice, and I think of the cell phone as being one that most of us can deal with or understand what it is, what our expectations are around it. But the idea is to quantify it in such a way that we set the system level or the top level goals. Later, then we break this down into subsystems. We work with vendors for component reliability. We alter the environment, say for the power supplies can be running at 15 degrees C hotter than the ambient. So it's got a different temperature environment. So it's also got different vibration. It's got different environmental conditions specific to that internal component. So we alter the function of the power supply is not to make and receive phone calls. It's to provide power to the rest of the system. And there's probably a requirements document associated with that. And then what's the budget for its reliability and the durations, which are probably the same. But the reliability factors for just the power supply are certainly going to be higher than just for the system overall. So, and let me take a, duration for an airplane. So, Elknor, I've done work with a couple of airline folks, and one of them is they want the reliability or the availability of the aircraft to fly passenger legs or segments, or to fly a mission, say in a military aircraft. They want it to be ready to go when it needs to be ready. And so it's a mix of maintenance and reliability. But during the mission or during the flight, it's all reliability, and depending on how much redundancy is built into the aircraft. But it might be say a 12-hour flight. So 12 hours is a critical point in time, depending on the flight durations for that particular aircraft. But the person that bought the aircraft wants more than just one flight. They want it to survive long enough that they make money based on the investment, or they get a return for their investment. So many aircraft are expected to last for 5 years before a major refurbishment or upgrades. But there are aircraft that have been flying for 30 or 40 years. With proper maintenance and refurbishment, they can continue to fly. Depending on your airline or on your particular conditions, you may be doing a 20-year purchase, knowing that you're going to do significant maintenance along the way. So there may be reliability for mission time, for flight time. There may be a reliability figure of merit for between durations of refurbishment or upgrades, maybe 5 years. And then for everything that doesn't get replaced during those refurbishments, say the airframe itself, it may be a 20-year reliability criteria or goals. And yes, I'm going to put the slides are here in the downloads file. I'll also post them up on SlideShare. Should be up there later today. And also I'm should have these available on, again, this entire screen will be available on the recorded part, where you log back in and you can see the entire recording, including all the live links and downloads. So that should be available there. So I don't see any questions in the question tab. A couple of different comments. Appreciate that. And with that, well, I guess we'll wrap it up for today. Thanks for participating. Ooh, the slide download link's unreliable. I didn't know that. It's the PDF document, establish reliability goals, the 9 megabyte one. Highlight it, download. Yeah, sorry about it being such a large file, but a lot of big images in there. All right, so let me go ahead and end the recording.